Now we are going to see some idea regarding academic writing in science, ethics in research, and research misconduct. So the topic of discussion will be what is called research, ethical standards in research and research integrity, reporting a research, art of writing a paper, and the next one is by managing citations. So let us see what is called research. We have seen in the previous lecture what is called research. By definition, research is systematic investigation into into and study of materials, sources, etc., in order to establish facts and reach new conclusions. That is called research. Also, research is defined as an endeavor to discover new or collate old facts, etc., by the scientific study of a subject or by course of critical investigation. Is actually how research is defined in Oxford Concise Dictionary. So in research, what we do, or we can say what is research. Okay, research is what we do when we have a question or a problem we want to solve. Okay, so for doing a research, for the first thing what we need is actually a research question. There should be something to solve. Then only we can do a research. We may already think we know the answer for the question. Sometimes we know that how to synthesize that. For example, in chemistry point of view, suppose if you want to synthesize cholesterol, you know different steps how to do it, but you may already have some idea how we can do it. But our answer seems to be obvious and as per common sense it will be right. Okay, but the answer will not be an answer if we don't do it that systematically. Our answer will not be an answer if we don't do it systematically. Okay, that's actually called research. So research is what we do when we have a question or a problem we want to resolve. We may already think that we know the answer for a question. We may think that the answer is obvious, clear, and the common sense also is prevailing. But we have subjected our problem to rigorous scientific scrutiny. Until we do this rigorous scientific scrutiny, our knowledge remains little or less more than a guesswork or intuition. Unless we prove our study by using systematic methodology, we cannot say that our problem is a worthy problem. Okay, so in research, our first priority is to formulate your research question. That's very important. The first priority is to formulate your research question. And after that, you have to figure out how you're going to answer that research question. And after that, you're going to present your research answer. There are the three very important steps when we start doing a research. It can be a project, it can be a dissertation, PhD dissertation, etc. Before doing that, you should know the question. For example, synthesis of a compound or study of adsorption of a material, preparation of a nanocomposite. Okay, by using this and that, that should be a research question. Once there is a research question, the research question is set by your supervisor, you have to think how we can solve that. The second type of thing. Okay, and after that, then you can present your answer. After that, you can present your answer. Okay, these are the different steps of actually research. So the second step is very important. The second step is actually says how we are going to answer. That's very important. To understand how we are going to answer it, we should understand three other things. The first thing is that how others have answered that. That's very important. How the others have answered that. You have to see how the other researchers answered the particular question or a similar question. Okay, so this can be only understood if you study the previous research papers. Okay, that is actually what is called literature survey. So we have to do a research detailed literature survey to see whether it is done by anybody else and how they have done. And second thing is that how does your proposal fit with what others have done? So how whether is there any whether your proposed method is same or your proposed problem is same with that of others, you have to do that. If others have done the same thing, there is no use of doing that again. Okay, and also the third thing you should know that how will you know when you answered it? So we have such question, and we should know how we get a solution for that question, and we should know how we can understand that we got a solution. For example, if you're going to synthesize a new compound, you can see that the new compound will be can be characterized by some spectral methods. If you take IR spectra, if you take NMR spectra of the compound, you can find it whether that compound is what you observe. So that's the point. Okay, there will be knowing whether you have answered it or not. Okay, and that comes, these three constitute the second step. We have to figure out how to go to answer it. Once everything is ready, you have answered your research problem, you have to present your answers. You can present your answers in different ways. So one is an oral way. Oral way, that means in seminars and conferences, you can present your research. Okay, and second thing is actually by written way. Written way is by submitting articles to the journals or by writing dissertations or project reports, etc. Okay, in classical scientific method, okay, these are the different steps of the classical scientific method. Sometimes it is not applicable to science people always, but it's actually what we people say in a general way. Okay, the first one is that the observation of some phenomena. We have to observe some phenomena. That's the first point. We have to observe some phenomena. Okay, that observation may not be systematic. It's not purposeful, but it may be occasional. Sometimes if you pass through a lab, you may find a new product. Okay, we got some unexpected product. That is actually what is called observation by accident. And if you see an observation, you have to have some idea of why it happened. You have an idea of why it happened. That's actually called hypothesis. You have an idea why it happened. That is called hypothesis. So you should have an approximate idea of why it happened. That's called hypothesis. And this hypothesis can be induction or by conjecture or by intuition or by guesswork. Or it can be generated by looking into previously related works. It is called hypothesis. And the next job is to test your hypothesis, but to find it whether it is correct or not. Okay, you can see an observation. For example, we have seen an observation. Okay, in a lab, we got a surprise product. So you may just what to do is that you may hypothesize that it is due to the acid present. Okay, that's the hypothesis. So we'll test the hypothesis with acid and without acid. If you got the product with acid, then we can say it is it can be acid catalyzed reaction. And if it is not getting in the absence of acid, then we can completely sure that it is happening in presence of acid. So we test a hypothesis. Next, again, what happens is if the hypothesis is not tested, then what happens? We have to make a new hypothesis. Okay, then test it. We get and see the results, and the cycle will repeat and repeat and repeat for a good researcher. And after that only he will get the correct answer for the observation he has made. You know, for aromaticity, many people studied aromaticity, and none of them are able to explain what is called aromaticity of benzene. Okay, they made different hypotheses. At last, Kekulé came with the electron delocalization principle. This is confirmed by different other theories. And see what is called hypothesis. Hypothesis is nothing but the probability of a research. Okay, it's nothing but a probability of a research. So, you know, nothing is certain. It's only a probability. Okay, so it is actually the scientific truth. Okay, and that is a statement. Okay, and it will be the one that matches closely with the experimental data. That's called a hypothesis. And for testing the hypothesis, we can having some experimental methods, and we had to employ statistical tools to them, especially if you're doing biologically related work, psychologically related work, social science related work. You have to test your hypothesis by using the statistical tools. The hypothesis is nothing but an intellectual guess of what is happening. Okay, so it may be a true, it can be true, or it may not be true. It may be true, it may not be true, that depends. Okay, now I would like to introduce you to three terms. One is thesis, antithesis, and synthesis. Okay, this is, the PhD thesis. Okay, now the term PhD thesis is replaced by dissertation. Let us see why it is so. Okay, so thesis is nothing but the original statement of an idea. That is called thesis. This is nothing but an original statement of an idea. So these days, people are not coming with original ideas. That's why we usually term as PhD dissertation. Dissertation is a report only. This is a new idea. As people are not coming with new idea, generally people are never called as PhD thesis nowadays. Earlier it was called PhD thesis, but it is called PhD dissertation now. Next one is antithesis. Antithesis is actually an argument to challenge the previous thesis. So in a previous study, we got some results. Okay, when you repeated the study, we got entirely different results. Okay, that is called an antithesis. So antithesis is nothing but an argument that is used to challenge the previous theses. That is called antithesis. Next one is synthesis. Synthesis is actually a new argument by using the existing resources or sources. Synthesis is actually a new argument. So synthesis is actually, we are making up a new argument from the existing resources. Okay, so actually this synthesis is actually what is happening during a thesis, in fact. This is original statement of an idea, and this is an idea or argument that is used to challenge the previous thesis. Then there will be synthesis. This is actually an argument from existing resources or sources. And typically it resolves the apparent contradiction between the thesis and the antithesis. That is actually what is called the three terms: thesis, antithesis, and synthesis. Okay, so there are different examples that we can say for thesis, antithesis, and synthesis. Let's think of an example. An original statement of idea, then came the antithesis, then came synthesis. A simple example, we can say that particle wave duality. Okay, so earlier classical physics people said that electron is a particle. Okay, but quantum mechanics people found that electron can, Davis and German experiment, electron can also behave as a wave. That's actually a new antithesis. It was against the belief of the previous knowledge. And from that, a new concept came that is called dual nature. That is the synthesis part. Classical physics say that electron is having particle nature only, and the quantum, we got observation that it can also diffract, so it can also be a wave. That's the antithesis. There we can say that it is having the nature of the wave also, and based on that we made a synthesis. That is a dual nature. That is actually the difference between thesis, antithesis, and synthesis. Okay, these are the different stages of the research process. The different stages of the research process. The first stage of the research process is actually to identify the problem, what you're going to study. That's very important. You should have an idea of what you're going to study. That is actually the first thing that you should do. To identify the problem or the broad problem. For example, I am interested in studying the non-covalent interactions between water and a molecule. Sometimes you may be interested in synthesizing a new compound. Sometimes another people will be interested in developing a new polymer blend or a new polymer composite. That's actually the problem. So you have to understand your broad area of interest. I like computational chemistry. Therefore, I am doing research in computational chemistry. But sometimes you may not like that. Okay, so you may have some other topic of interest. You may sometimes like medicinal chemistry, sometimes you may like synthetic organic chemistry, sometimes you may like analytical chemistry, sometimes you may like assay of the compounds, sometimes you may like pharmaceutical chemistry, sometimes you may like materials chemistry, like that. Okay, a second step is actually you identify the problem or the broad topic, and you have to read the existing materials, what is reported in that particular area. That is called literature review. That is called literature review. Second step is actually called the literature review. So when we do the literature review, we can find that if everything is available in literature, then that means that that problem is bugged out. So there is nothing else to be done. There is no scope for you. Okay, so here what we can do is that we can identify the gap of the research. You can identify the gap. If for example, if you are interested in doing, for example, I can talk from my context now. I was doing the study of hydrogen bonded compounds. When I started looking in literature, I found that almost all the compounds are studied, but thiols, thiols are having a SH bond. Thiols hydrogen bond is not actually studied before. So actually that is called a research gap. That is called a research gap. We have to identify what is not done. This can be only be obtained by doing literature review. First, you have to identify the area or the problem that you're going to study. Then you do the literature review. They will be getting an idea of what is actually done before, and identify the place where it is not done by others. And that is actually what is called your research gap. After doing the research, identifying the research gap, we had to identify some objectives for your research. Okay, so we got the research gap. We got the research gap. Okay, now the next one is that you had to set some objective for your PhD or your MSc dissertation. Okay, so we got the identify research gap, then you got setting an objective for research, your research. After doing that, setting the objective, you have to arrive the hypothesis. For science people, we may skip this step number 5, arriving the hypothesis, but actually it's suggestive. So you have to arrive at the hypothesis. Okay, why? What are the reasons, or what may be the probable answers for your objectives? After getting the hypothesis, arriving at the hypothesis, we have to decide the methodology, how we are going to test the hypothesis. That is called setting the methodology. We are going to set the methodology. Okay, now after okay, I will explain. Give an example. For example, I am interested in doing the synthesis of a Schiff base. I scanned through literature. I found that many Schiff bases are found out, have been synthesized before. But I was interested in the Schiff base between aniline, for example, and salicylaldehyde. But I found that it is not actually reported by anybody before. So what I did is that I got the research gap. My research gap is the synthesis of Schiff bases from aniline and salicylaldehyde. That's a research gap. And next, I am going to set up my objectives. My first objective is to synthesize the Schiff base. Second objective is to study the then second step is to characterize the product obtained by using UV NMR, like that. Third thing is that, for example, I had to study the medicinal activity of the compound. Third thing, because I am just telling you only. Fourth one is actually I am going to study the drug delivery property of the compound, objective. Fifth objective, I am going to tell how this Schiff bases can be used in analytical chemistry. So I have set 5 research objectives, and these objectives, then you have to reach the hypothesis. And the next one we should do is that we should set the methodology. For example, if you're going to synthesize the compound, you have to synthesize the type of synthesis that you are going to do. Sometimes you may do in solid state synthesis by using grinding. Sometimes you may use what we can say microwave. Sometimes you may use sound, ultrasound. Okay, so we have to decide what is the methodology. Next, we have to do the experiment and we have to collect the data. By using experiment, you can collect the data. You may synthesize and then send the compound to characterization, NMR and IR spectra. Then you can confirm whether the compounds that or not. Then you have to analyze the data. Okay, and from the data, you may reach a conclusion whether the compound that you synthesize is that or not. So this is actually a conclusion. After that, you have to write the report. After that, you have to write the report or the paper or dissertation. Okay, so if you cannot make this, if you cannot reach a conclusion, or if you cannot get a product, then what you do? You have to again come and do the same cycle again. Then again, you have to, that means the problem cannot be studied or tested. So what you can do is that you have to come back to this stage step 1 and do again literature review, then identify the gap and set the objective, arrive the hypothesis, set the methodology, do the experiment, analyze the data, reach the conclusion, and start writing. And if it is not going, do it again and again. That's why in some universities or some places like IITs, IIScs, etc., it may take a lot of time to finish your PhD. Okay, because they try one problem, and after 1 year they may find that it is not working, so they will stop there. After that, they select second problem and third problem, like that. And then only after 3 or 4 years only, then they will be able to finalize what the problem that they're going to study, and then study, and then it will take around 5, 6 to 7 years to finish the PhD. These are the research process. So this is actually what's called research process. We'll stop for the time being.